Hello everyone, and so we have done periodic table families, and we have done charges, finding charges in the periodic table, and now we're going to talk about periodic trends. And periodic trends are characteristics of elements that we can we can predict using the structure of the periodic table. And PT is periodic table, okay? And these are the four that you need to know. When you look up ones online, you'll see a fifth one that's metallic character. I don't really see a point in having you memorize that because most periodic tables, especially if you print one that's colored, will have a key that tells you what's a metal, what's a metalloid, and what's a non-metal. And so if you can find that information straight off the periodic table as it's given, I don't really see a need to review that because you know how to read. So these are the four that I'm mainly concerned about. Ionization energy. How much energy does it take to pluck an electron off? Electron affinity. How much energy is used, or released rather, how much energy is released when an electron is gained. Atomic radius. How big the atom is. And electronegativity. The ability to attract electrons. And so there's a video that you can watch on slide 17. This video here. This guy, the video isn't, the most high tech or anything, but he breaks it down into a very simple way of more like reasoning the periodic trends instead of having to memorize them. Okay. And so I think it's like a 3 to 5 minute video. It's really quick, and this video is a song to help you memorize them if you are better with memorizing, or if you just want a little tune you can sing while you're doing your take-home test, so that way you don't have to refer to your notes or whatever. So those are some tools that are there for you. This table pretty much summarizes the periodic trends that the guy goes over in the video, and so when we're going over this in lecture, if you're in my class, you don't have to write down every little thing as he's going through that video because you have it right here already written out for you nice and neat in a chart. So, but really quickly, just to summarize that video up a little bit, okay. I'm going to pull out a chart, okay. So this is something else you can use. You can just Google illustration of the periodic trends, like I did up here, and you'll find this type of chart if you find this more helpful. And so on the periodic table here, when we talk about, let's talk about ionization energy, for example. Helium, which would be here, has the largest ionization energy. The closer you are to helium, the higher ionization energy you have. And so I know like the elements aren't here, but if I were to ask you, like carbon's in here, and so if I were to say which has a greater ionization energy, carbon or lithium, which would be found over here, you're going to say carbon because carbon's closer to helium. That simple. Okay. With electron affinity and electronegativity both follow the trend of being higher the closer you get to fluorine, and fluorine is here. Okay. And so as you can see, electronegativity, electron affinity both follow the same trend the closer you get to fluorine. That's the highest you can get. And so if I were to ask you what has a greater ionization energy, gold, which is a transition metal, not ionization energy, sorry, electronegativity, gold, which is a transition metal found in here, or potassium, which is found over here, you would say gold because gold is closer to fluorine. And same thing for electron affinity, okay, as you get here. And atomic radius is pretty simple in that helium is the smallest. Yes, it is smaller than hydrogen. But with the exception of hydrogen, the fact that the smallest starts at helium and it goes, because you have 2 electrons here, it's 2, 3, 4, 5 electrons. When you have neutron atoms, 6, 7, 8. So the more electrons you have, the bigger your atomic radius is going to be, because the more orbitals you have, the more electron shells are being occupied. And so as you go down, you're going to have a larger atomic radius. And as you go this way, you're also going to have a larger atomic radius. And so helium is the smallest, and this element here, I don't remember it is, that has the largest atomic radius, okay? Because you're adding electrons as you go down. And so some people do it different ways. When I was in Gen Chem 1, I just wrote this out on a periodic table over and over and over again until I had it memorized and used it to answer questions on the test. If that works for you, if you want to use the reasoning that this gentleman uses in this video, that's also fine. If you want to use a song to help you memorize them, that's fine. But just really understanding the definition of it. Alright, so if I were to, I might give you hint, hint, wink, wink, nudge, nudge. I might give you vocabulary matching on this, and then I might ask you to rank 2 or 3 elements from smallest ionization energy to largest ionization energy. So this video is pretty short because this is pretty much just definitions and you figuring out which way you learn best, whether it's through memorization, whether you want to write it on your periodic table over and over again, or whether you want to do the song thing, whatever, to figure out the periodic trends and to be able to answer those questions on the test. You will have an interactive game where you practice it, and you would also have the Chapter 3 electronic structure review that also, I think that talks about periodic trends too. If it doesn't, then you definitely have it here in this interactive game to review. So these are your review problems. This is parts of the periodic table. There's a couple things in these books, because the booklets were already made, that you might have to Google. Not a big deal. And some of it you might already know if you took like a high school level chemistry about the parts of the periodic table, but these are some practice problems for you here, and these, if you are in my class, then they should also be under Canvas.